Okay, today we are going to practice interpreting and reporting the data that we've organized and manipulated and graphed, visualized. And we're going to use the slasher movie data set from tutorial 3. So hopefully you've already gone through that and have followed along to make something similar to this in Excel. But we'll go through and talk about how each of these things that we're going to talk about in the write-up were created. So the first thing that we want to talk about is summarizing the proportion of each variable's level. So looking at gender, how many males, how many females, and then transforming that into a proportion. For sexual activity, how many were sexually active, how many were abstinent, and for our outcome variable, how many survived and how many died. And remember that because this is a random sample, each movie had an equal likelihood of being selected for this sample, we can generalize this to the whole population. Any patterns that we see in the sample, we should find in the whole population, every slasher movie, if we compiled all of that data. So we don't necessarily need to visualize this, the proportions, but I should write something about each one, just to tell the reader what the data set looks like. You don't want to just list out the proportions, saying like 54.23% were male and 45.77% were female. You do want to include relevant interpretations as well. But these sentences can be simple and to the point. So if we just take a look, if there's anything interesting to report there, we see that about half the characters are male, half are female. That's pretty good. There's an equal representation. 2/3 are sexually active, 1/3 is abstinent, and a large majority of the characters die, which is why it's called the slasher movie. So let's just write something about that in our write-up. So we start with a blank one. So slasher movie characters are almost evenly split across gender. You do want to report the actual numbers for reference, but you don't need to graph them. Just some males and 45% female. Here, I'm not making any interesting interpretations about the sexual activity, so I can just give them one proportion, and since it's binary, you're either sexually active or not in this data set, you can just give them one. And then, like I said before, a large majority of the characters die in the movie. We want to give them, again, the numbers specifically. And if it doesn't fit in our sentence, we can just make an aside like this. Only 17.5% survive. Next, we can look at the frequency of survival across the different groups, just looking at a single predictor. So I've already graphed these out here. But within each variable's level, so we have the variable, predictor variable, gender, and the level of male. We used Excel to count how many. Right now we're looking at one predictor crossed with one outcome variable. How many males survived? How many females survived or died? And when we're looking at the variable sexual activity, we're doing the same thing, asking the question, how many sexually active died? The base rates here are different, so we don't want to visualize the counts themselves. We want to visualize the proportions, and we want to do that in a way that is not misleading. So we've talked about the dividing by the predictor. So what that looks like, you can see everything is kind of contained in this one row. Males, this is how many survived versus died, and then we add it up for the total, and then we use those same cells in that row to get this proportion. If we are interested in the question, what is the proportion of abstinent characters who died, what do we divide by? What is our total that we use for the base rate? We say it right in the question. What is the proportion of abstinent characters? So our total is the number of abstinent characters. That's what we're dividing by here. You can see this is the base rate. So let's take the two graphs of our two predictor variables and see if there's an effect of each variable on survival. I'm going to put both of my charts in, copy, paste, put this down here. So when I hit Control V or Command V, it pastes it as a chart. And I can still edit different parts of the chart. So if I want to make this a different color, if I wanted to change the title, move it around, I could still do that. But it makes resizing the graphs kind of difficult because things get a little bit wonky. So my labels are off. So what I want to do, I'm happy with how my graph looks. What I'm going to do is paste it as a picture. So I'm going to undo my paste, and you can come to Edit, Paste Special, and instead of having it as a graph, I want to just make it a picture. And put it like that. And this way, if I make it smaller, the whole thing just gets smaller. I'll do that for my other graph. Copy. I can also right-click and paste special here. Or if I think of it right afterwards, this little guy is asking, is there a different way that you want to paste it? And there is. I want to paste it as a picture. And again, I'm going to make that a little bit smaller. Maybe up there. Same size-ish. I also want to decide how my picture fits with the text. So let's see if I can find this on here. So I've selected my first graph, and I'm going to click on the format. And let's see. So here I can pick position if I just want it to slide. Specifically, I want it to be in the upper right or left-hand corner, upper right, in the very center. I like doing things with wrap text. So for this one, I'm going to put it in front of the text so that I can. This means that I can move it around wherever I want and make it lined up with my text manually. So now I'm going to check my graphs. I always want to go through a checklist with every graph to make sure that it contains all of the components needed. So I'm going to check my title on both of them. I think I have a good title. Outcome variable by predictor variable. Outcome variable by predictor variable. Pretty clear, straight cut. I want to make sure that all of my axes are labeled. So here, my y-axes are the same in both of these graphs. Proportion survived, and these are in percents, which is correct. And for my x-axes, I'm just putting the variable label. So this is gender. I have my two levels of gender, male and female. And over here, I have sexual activity status and the two levels of that, which is sexually active and abstinent. I also want to make sure that my y-axis is appropriate for my data. So as I said, we're doing proportions, and I have my percents signs in here. But also, I don't have extra decimal places that aren't giving us information. I got rid of those earlier. The range is appropriate because this is only going up to 22%. So I don't need to go, up to 50%. That's kind of wasted space. And I'm going all the way down to 0 on both of these as well. And I've made the axes equal in both of these. So if I just wanted to look at the proportions, I can compare those easily. Let's see, what else? And also the increments are appropriate for this data. It's easy to compare these and see what exactly that proportion is, somewhere between 10 and 15. So I have these in 5% in increments. One other thing that I always want to do is make sure that my figures have names. So I'm going to be really creative. This is my first one, so I'm going to call it figure 1. And this one I'm going to call figure 2. You always want to name your image, your graphs, your tables, anything that you put in there, so that you can reference it in the text. You want your reader to be able to find the appropriate graph to look at. Let's interpret these graphs. So first of all, we can look at how gender predicts survival. We can reference that in figure 1. We can see that females survive almost a quarter of the time, while only 14% of males survive. Sexual activity also seems to predict survival. You can see that in figure 2. Abstinent characters, looks like they're twice as likely to survive as sexually active characters. So it's about 20, about 10. So those are the kinds of interpretations that we want to draw our readers' attention to. So, when looking at how gender predicts. Again, I want to reference that, tell them where to look. Figure 1. See that almost a quarter. Males survive. Only 13.31% males survive. And we want to put the actual number in there for them. What do we here? Almost a quarter, specifically 22.52%. So that sums up our interpretation of how gender predicts survival. Sexual activity, on the other hand, in the movie predicts survival. And I'm going to draw their attention to figure 2. So absent characters, what did we say? They were twice as likely to survive as sexually active characters. Again, let's add those specifics. Twice as likely to survive. Specifically, they had 20. And the sexually active characters were at about 11. Okay, so now let's look at the frequency of survival in our multivariate groups. The point of this is to see if the patterns are the same for each variable, the same that we found in our univariate visualizations. If the patterns are the same for each variable regardless of the level of the other variable, or if one variable is influencing the other. So for example, from our univariate visualizations, we can see that being sexually active decreases your risk for survival. But we want to know, does it reduce the rate of survival the same for males and females? Another equally valid way of thinking of that is we know that being female increases your chance of survival in these movies, but does it increase your likelihood of survival regardless of whether sexually active or abstinent? So those are both the same kind of question, and they're both equally valid. It just depends on what we want to know and what makes the most sense to visualize. Okay, so to do that, we made a larger contingency table in the tutorial. Again, we're counting how many died versus survived in each group, but now we're combining the variables into more specific groups. So how many characters were not only male, but male and sexually active? How many of those people survived? Of the males who were abstinent, how many of those people survived or died? And so we do this for all variables, looking at both levels of gender, both levels of sexual activity. So as before, the base rates are very different here, so we want to visualize the proportions. And the same rules apply for getting these proportions and using the base rate. So we're looking at percent survived in each case. So we want to know in this group, males who were sexually active, how many survived out of the total number in that group, males sexually active. So we would take this divided by this, and that's what we've done. So we do that for all 4 of the groups. We've just moved these down into an easier format to grab and put into our bar graph. These numbers are exactly the same. So males who are sexually active, that's what we have. Males who are sexually active, this one. And these are all the survival rates. So we've made another bar chart. Because we have multiple predictor variables, we have a legend this time. We have one variable, gender, across the x-axis, and each level of gender has both levels of the sexual activity variable. So for the level male, I have sexually active in the dark bar and the abstinent in the light bar. I'm going to go through my checklist again because, again, I want to make sure that everything looks nice before I put it into my graph. I have a nice descriptive title where I have my predictor, or my outcome variable, survival, by my 2 predictor variables, gender and sexual activity. That's pretty straightforward. Both of my axes have labels. As always, we have proportion survived. And in this case, I'm putting the fixed predictor, gender, across the x-axis, and the sexual activity in the legend. And those are appropriately labeled, they make sense, and the colors are easy to distinguish, even if we were printing this in black and white. And in this case, we also want to make sure that we have a gap here, because these are not conveying some sort of continuous order. So if this was, young, if this was age, young and old, then maybe we'd want those touching, conveying that this flows into this. But because sexually active and abstinent are not continuous variable, there is no first and second, we don't want those bars to be touching. So let's put that into our write-up and take that over to my write-up, paste it. So right now it's still in the form where I could change something if I wanted to, but I think I want to keep this as a picture. So again, I have this little toggle, I can paste it as picture. I'm not sure why the colors change, but it's a problem for a different day. So again, I want to choose how my graph is going to fit in my write-up. It's getting a little crowded, so let's zoom out and see what things look like. I think for this one, I want to put my graph over to the right and then have all of my words that correspond, my sentences that correspond to that on the left. So in order to do that, again, I'm going to come up to the picture format and I'm going to select wrap text. And instead of doing in front of the text, I I think I want to put it as square here. If you're using a different version, or if you're on Windows, this might look a little different. These buttons might be hidden under a single button called Arrange. If you ever can't find something that we're talking about, or that you want to do, you think Excel or Word should do, just click around. Go through all the menus, click things, try them out. If all else fails, just Google it. Someone else on the internet has already asked the question that you want to ask. Okay, so what am I missing? What do I always have to put for every single one of my graphs? A name. Figure 3 for my third figure. What do I see in these data? One thing that we notice right off the bat is this doesn't look additive to me. This looks like there's an interaction. The pattern here is not the same as the pattern here. The pattern within the males, not the same as the pattern in the females. And that means that the variables are influencing one another. Here we can see specifically, there's not really a large difference in the rate of survival for males who are sexually active. They still have pretty low chance of survival. However, when we look at the female characters, those who were abstinent were twice as likely to survive as those who were sexually active. So that's a big difference. In fact, the sexually active females were just about as likely to die as the average male. The sexually active females, their survival rate was 13 point something. And that's the same as the average male. They die 13 point something % of the time. So that's a very interesting pattern, because before we thought females were safer, but it turns out only if they are abstinent. So let's write that up. We want to start off, spoil the story, tell them a very strong statement. There is an interaction between the variables gender and sexual activity. Oops. There's an interaction between the variables and sexual activity. How so? On survival. And we also want to tell them where to look. Check out figure 3. So first we can look at the males. There was not a large difference in the rate of survival. For males who were sexually active, how many of those? 9.46%. And those who were abstinent. Again, how many exactly? Tell the reader, 14.81%. However, looking at the female characters, those who were abstinent they were the ones who were twice as likely to survive as those who were sexually active. And what else did we notice? We want to draw the attention to, in fact, sexually active females were just as likely to die in the movie. How much? 13.25% as the average male. Make that clearer. One thing to notice, I'm not just saying males are the same. Females are twice as much. That's not really helping the reader. You want to make it very clear what we're talking about. A large difference in what? Difference in how many there were, how many died, in the rate of survival. And we always want to include what it is that we're interpreting to survive. They were just as likely to die. Okay, and I said before I wanted to put this over here, so because this is in square format, I can just kind of push this over here. Make this a little bigger so people can see it. I've lost my figure name. I'll put another one. Figure 3. Okay, so finally we want to write a conclusion. We want to look at the main points that we made in our graphs and summarize them in the context of our original question, which was, what characters survive a slasher movie? So we can go through and summarize. First we looked at our single predictor. In conclusion, both gender and sexual activity individually predict survival in a slasher movie. Slasher's not a word? Specifically, we want to point out what differences we did find. Female characters and abstinent characters are more likely to survive. Then we want to talk about what we found when we compared the influence of each variable on one another. So it's not just that female characters and abstinent characters do better in a slasher film. We see that the effect of sexual activity on survival is dependent on gender. Males are likely to die regardless of their sexual activity in the movie. But the pattern is different for females. While females can increase their rate of survival by not engaging in sexual activity in the film. Lastly, we want to end with a concise sentence that just summarizes all of the findings into something easily digestible for the reader, something relevant to the original question. So we could say something like, if you're watching a slasher film and see a character who isn't female, who isn't specifically a female virgin, you shouldn't expect them to make it to the end. So that looks pretty good. Let's zoom out again and see just what it looks like. Overall, we've talked about the makeup of the data sample. We've looked at individual predictors, and we've looked at our multivariate predictors. We've added some sentences that make it easy to understand what's happening in the graphs, as well as the relevant interpretations that the reader should be making. And finally, we give them a conclusion, something nice to wrap up all of the information together and kind of consolidate it into an easily digestible idea.